Welcome to the next in the series of the HAI installer training modules. This module will focus on energy management. The Department of Energy statistics show that around 56% of our energy costs are from heating and cooling. This is a US statistic, and clearly in the US there's quite a lot more air conditioning and cooling that takes place. But in the UK, I think we do quite a lot more heating due to our weather conditions. So I think that statistic is not far out. And certainly we've seen massive increases in energy costs, both electricity, gas and oil. So it's something worth keeping an eye on and gives you an opportunity to offer real cost savings to your customer if you were to implement some intelligent heating control solutions. During the security module, I gave you the example. If you were to set your thermostat back to a lower temperature whenever you armed the alarm, clearly we know the house is empty when the alarm is armed. So that's an opportunity to save money. You're not heating the house to the same temperature when there's nobody there. And when you come home and disarm the alarm, you can automatically bring the temperature back up. Even if it's only just for a couple of degrees centigrade over the course of a year, that's real savings. So that's where I think we can add a lot of value. HAI have produced it's unfair to call it a thermostat, quite frankly, because it does a lot more than that. It's a thermostat, it's a timer clock. It really is a heating control module in its own bit of hardware. It's available in a number of colours, and you can customise the displays in terms of background colours and how much information is shown on the display. So it's quite a unique piece of kit, and we've not found any heating systems that we're not able to integrate with in some form, be it underfloor heating, radiators, blown air systems. So it's a very flexible piece of hardware. It's available in two forms. There's the RC1000 and the RC2000. The bulk of what you'll use day to day is the RC1000. That's capable of handling most heating systems for both heating and also air conditioning, cooling. So that really meets the bulk of the requirements. The RC2000 is a bit more sophisticated. Notably, it will measure humidity. That allows you to trigger humidifiers and dehumidifiers to keep the humidity within a certain range. That's useful for certain areas, wine cellars, perhaps libraries, or where important documents are stored, or greenhouse type areas. Allows you to monitor the humidity and take action accordingly. Additionally, the RC2000 allows for multi-stage heat pumps and dual fuel systems. So if you're familiar with heat pump systems, they're getting very popular now with self-builders and new builds, because they are very eco and green and efficient way of heating your house, be it air source or ground source. However, some of the air source heat pumps tend to, because they operate based on the temperature differential from the outside temperature, they're working down to lower and lower temperatures all the time, but sort of around the sort of 0 to 5 degrees centigrade outdoor temperature, they start to become quite inefficient. So typically someone with an air source heat pump will also have a gas boiler. And the RC2000 can work with an outdoor temperature sensor to measure the outdoor temperature, and then switch between the air source heat pump and the gas boiler depending on the outdoor conditions. So that's what we mean by the sort of multi-fuel systems. So you'd need an RC2000 to cater for that. But like I say, the RC1000 is something you'll use most of the time. It has some quite handy runtime graphs where you can see how many hours that zone of the property has been running the heating for over the last 4 weeks. So if you do make a change to try and improve your efficiency by perhaps knocking the nighttime temperature down a degree, or your away temperature when you're not there, knocking that down a degree, you can then look back over the course of 4 weeks and see how many hours savings you've made by making that change. It's also got a full timer clock in it. As you can see from this screen, you have the concept of morning, day, evening and night, and I can specify a time range for morning, when clearly in this example morning starts at 6 AM, day starts at 11, evening at 5 PM and night time starts at 9 PM. And I can specify different heat set points and cool set points for each of those time ranges. Sorry for the Fahrenheit on the screen. Clearly you can switch it into Celsius as well, but my graphic is in Fahrenheit. So obviously a heat set point is where you want to heat to, and a cool set point is when you get up to a certain temperature that you want to cool down to if you have air conditioning. You can set the thermostats up in heat only mode if you don't have air conditioning in the system, so that's an option. And then of course you can copy and paste these programs between each day of the week, or they could all be different if so be it, but traditionally you normally have the same thing Monday or Friday and then something else on a Saturday and Sunday. The thermostat itself comes in two parts. As you can see from this picture here, the rear section is what is mounted to the wall, and the rear section has two screw down terminal blocks. You have one on the left and one on the right, which is your interconnection. The one on the left is the one that connects to your heating controls, and the one on the right connects back to the HAI controller to provide telemetry back to the main unit. And then the front section simply snaps over, and then all the connectors hook up at the same time. So we're going to talk through those connections. Looking at the right hand terminal block, there's 3 cores of a Cat5 required to hook the thermostat back to the main HAI controller. You lose one of the outputs and one of the zones. So if you remember from the introduction module, there are 8 outputs on the controller. These are normally used for controlling things, for switching 12 volt 100 milliamp to be able to control other relays or devices. So you lose one of the outputs and one of the zones. The zones are inputs that you might have your PIRs or door sensors or anything that's a volt-free contact that you want to trigger from. So zone 16 and output 8 get used up. 3 cores of a Cat5 connected up to the terminals. It's all color-coded and labelled on the actual unit, so it's fairly straightforward to do. All thermostats hook onto the same pins, whether it's one thermostat or maximum of 64 thermostats on an Omni Pro 2 or a Lumina Pro. They all hook to the same pins, so you can actually daisy chain them one after the other, and then in the setup menu of the thermostat you give each thermostat a unique address, being addressed from 1 through to 64. So it's a bus technology that links all of the thermostats back to the main controller. On the left-hand terminal block, we've got pins 1 and 3 are used for power. The thermostat is driven by a 24-volt AC power supply, so you need to buy a power supply. There isn't a great deal of current draw off these things, so 4 thermostats off 1 power supply is fine. We supply the same 24-volt AC power supply for the HAI controller as we do for the thermostats. That's a 4 amp power supply. So 4 thermostats on 1 power supply is, and there's plenty of headroom there. You then have pins 6, 7 and 8. In simple terms, if the thermostat needs heat, i.e. the current temperature is below the heat set point, then pin 6 goes live with 24-volt AC. If the thermostat requires cooling because the current temperature is above the cool set point, then pin 7 goes live. You can never have pin 6 and pin 7 live at the same time, because if you bring the cooling set point down to where the heat set point is, then the heat set point starts to move down as well. So you can never have the cool set point below the heat set point, because that would be silly, because clearly you'd have your air conditioning fighting with your heating system. So you can't get into that situation. So pin 6 and pin 7 go live regarding whether or not you're wanting heating or cooling with 24-volt AC. The pin 8, the fan, that is used for blown air systems. Not very common in the UK. This is where you typically have some kind of furnace or boiler which heats up the air and it gets blown through ducting throughout the property, and this allows us to control the fan separately from the furnace or boiler. So that's the connections. So very flexible, because pretty well you can wire that anyway into anything you like. But conventionally, here's some examples of how we would wire this in a domestic heating system. In the UK, we have a lot of radiator-based heating systems, and anyone that's got a radiator based heating system in their house, they will have one of these three-way valves shown here on the bottom of the wiring diagram. That three-way valve is fairly pivotal, and most electricians will be familiar with these. In a simple terms, what happens is the bottom of this valve is connected to the boiler, so hot water is fed from the boiler via a pump into the bottom of the valve here, and when we want heating, the valve opens up so that hot water flows out the left hand side into the radiators. And when we want hot water for our hot water taps, the hot water from the boiler flows out the right hand side into the hot water tank, and there's a pipe that runs up the middle of the hot water tank with that boiler temperature hot water in it, and that heats up the water in the actual tank. So when you turn your hot tap on, it's nice and hot. So very, very simple. In order to make that happen, the motorized three-way valve has a cable connected to it, and this cable here, shown connected to the silver motorized actuator, has a number of pins on it. And if the electrician has wired it incorrectly, then by applying 240 volts on one of those pins will make the valve open and feed the hot water tank. Putting 240 volts on a different pin will make the valve open and feed the radiators. And if you put 240 volts on both pins, then it will do both. So that's fairly simple. And then when you take 240 volt away, then the valve closes on a spring. A spring drives it closed. So what do we have to do? Well, here's our thermostat that's connected up to its 24 volt AC power supply, and here's my pin 6, 7 and 8, which is on the back. It's actually on the back of the thermostat, as you know. So when when the thermostat needs heat, because the current temperature is below the heat set point, then pin 6 is going to go live. So all we need to do is use pin 6 to drive a relay. This little relay here is a 24 volt AC relay, and that will make a circuit between the common and pin 6. So within your 24 volt AC world, we think of it as a common and a hot. So we're making a circuit between the common and pin 6, because pin 6 goes live with the hot when we want heat. That energizes the relay, and that switches 240 volt switched live through to our pin, and that then the little motorized actuator opens and hot water flows through to our radiators. And when the temperature increases sufficiently to be greater than the heat set point, then pin 6 will die, the relay will not be energized, the switch 240 volt will also die, and then the valve will close via its spring. So that's how we can control the heating on a conventional radiator based system, by switching 240 volt via a relay. Relays are generally available, electrical wholesalers, or there is a link to IMO sell a lot of relays on. If you go to our website at ordersystems.co.uk and go to HAI and the energy management, there's an area there that says useful information. There's some links to the IMO website where you can buy a 24 volt AC relay and a little enclosure to put it in. The relay would typically be co-located next to the three-way valve, and the thermostat could be anywhere you like, on the wall, in the hallway, or in the landing. And you can use Cat5 to send your power to the thermostat, and you can use Cat5 to bring pin 6 back to the relay, because 24 volt AC is deemed extra low voltage, and we can do that on Cat5. Obviously you need a Part P certified electrician to hook up the 240 volt side, to ensure it meets all electrical regulations. In that discussion, obviously, for the hot water to flow when we liven up pin 6 and liven up the relay, we need the boiler to fire up and the pump to start pumping water. We actually don't have to worry about that, because the three-way valve has an end switch in it, which provided it's been wired up correctly by the electrician. When we put our 240 volt on that particular pin, then 240 is then passed through to the boiler and the pump. So the boiler fires up and the pump starts pumping. So we actually don't need to worry about the boiler and the pump, because that will happen automatically simply by energizing the three-way valve, which certainly makes our life nice and simple. What about the hot water? Well, that other pin on that three-way valve gives us hot water. Now, with hot water, you normally have that on a timer. So perhaps it comes on for an hour in the morning and an hour at lunchtime and maybe an hour or two in the evening. So we can wire from one of the outputs. Remember, we've got 8 outputs on the controller that generate 12 volt 100 milliamp. Also on the same on our website is a link to the IMO website that do 12 volt to 240 volt relays. That will allow us to switch off and on the 240 volt to the other pin that will give us the hot water. And again, when we energize that, the boiler will fire and the pump will fire, but the hot water will only be going through the hot water tank, unless of course the thermostat is calling for heat as well. So this can be set up on a timer. With the programming of HAI, you will see that there are some user settings. The user settings are basically variables that you can allow the end user to customize. So instead of hard coding into the programming for the boiler for the hot water timing, come on at 6, go off at 7, you can actually say come on at user setting 1 and off at user setting 2, and then the end user via the iPad or the touchscreen can specify what time the user setting 1 and user setting 2 are. Obviously you're going to use up 6 user settings to be able to come off and on 3 times throughout the day, but it gives the user the flexibility to be able to do that themselves. And of course you can always add a button to the touchscreen for, turn the hot water on now, because someone's used the hot water and I want to put it back on again. Of course, there's normally also an immersion heater in the hot water tank, which is also a 240 volt device, which could be wired from another of the outputs via a 240 volt relay. And again, a button on the touchscreen can say, turn the immersion on to heat up your hot water, which is obviously normally pretty quick. With most modern immersion heaters, will heat up the water in a hot water tank in 10-15 minutes. So that's how you'd cover off the hot water, and user settings allow the end user to be able to control what time it comes off and on. So what about underfloor heating? With underfloor heating, we have a zonal based system. And by definition, we want to manage the temperature and the heating in each zone independently. So to do that, clearly you're going to need multiple thermostats, one on each zone. So what we've got here, we're showing a 4-zone system with 4 thermostats. And at the bottom down here, we have the underfloor heating manifold. So an underfloor heating manifold is basically 4 valves. It's a number of valves, which we call actuators in the underfloor heating world, but they're essentially valves. And hot water will come in from one side of the manifold, from the boiler, and it will flow out the other side and return back to the boiler and run around and around in circles in a big loop. Unless any of the actuators or valves are open, in which case hot water will flow out to the wet underfloor heating, which are pipes that are embedded in the floor, in the screed of each room. This is a much more efficient heating solution. Underfloor heating typically heats to only about 30 degrees centigrade, so it runs at a much lower temperature, whereas your radiator-based heating systems run at 80 degrees centigrade. So you're using a lot more energy, you're working the boiler harder, which shortens the boiler's life, and you're using more energy to heat that temperature up to radiator temperature. So underfloor heating is very popular. Any new build or refurbishment normally puts underfloor heating in my experience. So what all we need to do here is via the thermostat in each zone is open and close the actuator. Now I'm showing here 24 volt AC off my pin 6 going into a relay, switching the actuator at 240. However, all modern manifolds that I've seen offer the actuators in both 24 volt AC and 240 volt AC flavors. So that's why the thermostat runs at 24 volt AC, and that's why it switches 24 volt AC to be able to line up with connecting to the actuators directly. So should you have a 24, if you manage to spec 24 volt AC actuators, you can connect directly from the thermostat straight onto the actuator, and you don't need any 240 volt relays, which makes the installation very tidy and very simple. So try and get in there early and talk to the plumbing engineers and tell them you want 24 volt AC actuators rather than 240, and that gets rid of all those relays, which is less things to wire, less things to go wrong. So keep it simple. So now whenever any of these thermostats require heat, we will be able to open the actuator and allow hot water to flow through the wet underfloor heating. And if the thermostat says the room's warm enough, then the actuator closes and no water is flowing underneath the room, allowing it to cool. Now in this situation, we need to think about how we're going to control the pump and the boiler. The pump and the boiler, in a lot of systems, the boiler is kind of free running, because in this situation we're running at 30 degrees centigrade, as I mentioned earlier, and some boilers have their own little display on the front, and they just free run and they just keep the water topped at 30 degrees centigrade. Some statistics I've seen indicate that letting the water cool down and then heating it back up again to 30 actually uses more energy than just topping it up to 30 all the time. Especially if all the thermostats don't need heat, the water is just cycling between the boiler, going through the manifold and back to the boiler again. It's not going anywhere, so it loses very little heat. There's very small amounts of energy are required to keep the water running at 30 degrees centigrade. However, should you want to turn the boiler off, you can by wiring that into the relay as before, and this time into the one of the outputs, and that allows us to turn the pump and the boiler off. And there we'd need to write a little bit of logic in automation programming that basically says if any of the thermostats need heat, then turn the pump and the boiler on. And so that will be an or statement. If the first thermostat or the second thermostat or the third thermostat or the fourth thermostat need heat, turn the boiler on. For turning the boiler off, all thermostats would need to be showing that they're hot, that they're warm enough, and then you can turn the boiler off. So that will be an and statement. So if the first thermostat is hot enough, and the second thermostat, and the third, and the fourth, then you can turn the boiler off. So turning it on is an or statement, and turning it off is an and statement, and that can be done within PC Access automation programming. If If you are using any of these air conditioning manufacturers, Daikin, Mitsubishi, Sanyo and Toshiba, then we also have a very neat integration using the Coolmaster. The Coolmaster is a single standalone device, and it allows us to talk directly to these manufacturers' air conditioning systems, and each aircon unit actually shows up as a thermostat on the system. You don't need to buy a thermostat, and we can turn these air conditioning systems, we can adjust their set points and manage them. Within this environment here, you can see I've got 4 internal units on this particular property, this project, and there's an external unit, and they're all connected together on a 2-wire bus system, and the Coolmaster links into that 2-wire bus system, and then we can connect to it via RS-232. So the Coolmaster is a known connectivity partner. And then, as I said, each of these aircon units in each room show up as a thermostat. So we can read the current temperature and we can set the heat set point, or we can set the set point, be it for heating or cooling. You can set one set point, and then the unit can heat to that point, and if it increases over that point, it can cool to that point. So you've got total control over the temperature in that particular zone. So if someone that's using Mitsubishi or Daikin or any of those manufacturers, you can integrate that into your HAI system very easily. Looking at some of the PC Access aspects of things, I'm going to run up PC Access and show you some of the aspects of how to do some of the programming. Okay, so here we have the PC Access software in front of us. To put your thermostats in, remember we have the Setup tab on the left hand side. It is very simple. Down here we have thermostats. This is an Omni 2E, only has 4 thermostats. The Pro, the Lumina or the Omni Pro 2 can support up to 64 thermostats, and the Lite only supports 1 thermostat. All you really have to do is name your thermostat by clicking here, and you can type in its name. Voices are for the dial service, so if you are going to use dial up and dial into the HAI system, you get given a menu structure, security, lighting, thermostats. If you don't give it a voice, it'll say for thermostat 1 press 1, for thermostat 2 press 2. Whereas if you give it a voice, then it'll say for the kitchen thermostat press 1, for the dining room thermostat press 2. So if I want to add more thermostats, excuse me, I can do so very quickly by adding their names. And then of course by adding the voices, I click here, and then I can type in dining. I'm just typing on the keyboard and it finds the word for me, and I can have up to 6 words in my sentence. In fact, I need to use 2 words for upstairs, as you've seen there. Then over here we specify what the thermostat, what its behavior is, whether it's heat only or cooling only or auto heat cooling, which is what I'm going to set them up as here. And you can see the addresses are being auto assigned on the right hand side there. So that allows me to know what addresses that I need to now go and set on the individual thermostats, actually physically the physical thermostats via the setup menu. So that's how I add my thermostats, very simple. And then when I connect and download that to the controller and boot up my touchscreen or boot up my iPad app, then my 4 thermostats will be listed, and I'll be able to see the current temperature and set the heat set points and the cool set points accordingly. Just want to show you if you wanted to do the boiler control, how you would do that within automation programming. So this is the underfloor heating example, whereby I want to be able to turn the boiler on if any of my thermostats need heat, and turn the boiler off if all of my thermostats are hot enough. So I've gone into automation programming and click on trigger. Now we've got a really handy trigger which is jolly useful, called every, and that allows me to do something on a regular basis. So I could say every 10 seconds I could then check my temperatures. The action is going to be to turn the pump on, and we also want to be able to turn the boiler on, which unfortunately I don't have a boiler in my list of devices. So I'm just going to very quickly nip back over to Setup and go to my outputs, and perhaps I'll change my towel rail to boiler for the purposes of this exercise. Go back to my example, and rather than turning the sprinkler on, we're going to turn the boiler on. There we go. So the outcome of this will be to turn the pump on and the boiler on. So now I need to get some conditions in there. The conditions are under temperature. So if the kitchen current temperature is less than, there's a temperature, a property of the thermostat is the kitchen heat set point. So if the kitchen current temperature is less than the kitchen heat set point, we want the boiler on. And then I can go copy and paste for my 4 thermostats, and then all I have to do is go in here and change it to the dining room is less than the dining room heat set point. If the living room is less than the living room heat set point, and if the upstairs current temperature is less than the upstairs heat set point. Oops, I clicked too many times there. So now you can see I've got the logic in place. However, as I mentioned, this needs to be OR statements. So I need to inject an OR into each line item, so that it's if the kitchen thermostat needs heat, or the dining room thermostat, or the living room thermostat, or the upstairs thermostat. So if any of these thermostats need heat, turn the pump and the boiler on. Now I can hit OK, and that piece of programming will now allow me to turn my boiler and my pump on. Of course, they could be wired into one output, and then I only need to have one output turn on for both, because I don't think you'll need a situation where turn the pump and the boiler on separately, but you get the idea. To turn it off, I'm now going to go copy and paste and open up that automation block. The outcome of this will be to turn the pump and the boiler off. This time it's if the current temperature is greater than the kitchen heat set point. If the dining room temperature is greater than the dining room heat set point, and if the living room temperature is greater than the living room heat set point. And then finally, the upstairs temperature is greater than the upstairs heat set point. And I want to remove my ORs, because this needs to be this is an AND statement. All my thermostats must be at the appropriate temperature in order to turn the pump and the boiler off. So that now allows me, these 2 automation blocks here are going to allow me to turn the boiler on and the boiler off. Hope you found that useful. I also, during the presentation, talked about the Cool Master. The Coolmaster connects to the control system via a serial port. So under expansion and serial, this is where we need to set up our Coolmaster, and Coolmaster is in the list. It's a connectivity partner. We know how to talk to it, so you can just select Coolmaster from the list of items in the serial port, and in this case I've plugged it into serial port 5. Then if we go over to back to the thermostats, we can add each of the aircon units in each room, each zone, to my list, and this time we're going to click on the address and we're going to tell it it's a Coolmaster. And then I need to put in the adapter, the system and the unit ID, which are IDs set up by the air conditioning company that are uniquely identify each unit. Once I've done that and I hit OK, then the system will start talking to the Mitsubishi or the Daikins or whatever aircon units it is via the Coolmaster. You don't need to buy any thermostats. The actual aircon units are the thermostats, and they'll show up in the HAI touchscreens and the iPad as thermostats. So that's pretty straightforward, pretty easy to do as well. Okay, other things we have as well, very popular, is the flush mount temperature sensor shown on the right hand side, where you want to avoid having the thermostat on the wall. Certainly where interior designers are involved in HAI projects or any particular projects, they like to minimize how much goes on the wall. The flush mount temperature, we're the only company with a flush mount temperature sensor that can get buried in the wall, and you can actually skim over it with 1 mil of plaster. That connects back to the actual thermostats. Now the thermostats would live in the cupboard next to the manifold. That makes wiring very easy, because the 24 volt AC pin 6 wires straight onto the actuator. So you can line up all your thermostats on the wall, label them for each room, or each zone they're controlling, and they're all positioned just above the manifold. Little piece of cable going from the thermostat onto the actuator makes the cabling very simple. A lot of our customers will just do this by default. The remote temperature sensor is relatively inexpensive. You can add those to each room, and it's 2 cores of a shielded Cat5 connects the temperature sensor back to the thermostat. And then you've got invisible temperature sensors, no wall acne with various things stuck on the walls. Certainly some high-end properties tend to use very expensive, sometimes silk wallpaper, and you really don't want to be mounting a thermostat on the wall in those circumstances. So the flush mount temperature sensor is a very popular addition, and in high-end homes and high-end properties is absolutely appropriate. The surface mount temperature sensor is available as well, not quite so aesthetically pleasing as the invisible sensor. So the invisible sensor is the one that's the most popular, and I would encourage you to use and spec it in. Basically spec it in. Your customer will thank you for it afterwards. For wiring this in, as I mentioned, it's 2 cores of a shielded Cat5 is used to connect back to the main thermostat. It is a passive device. There really is nothing to go wrong. We've never had any of them come back. So you can rest assured that when they're buried in the wall, provided they're fitted correctly, they're going to work they're going to work forever. They connect back to the right-hand terminal block on the right-hand side of the terminal blocks on the thermostat. And you must remember to go into the thermostat settings via the main menu on the thermostat itself, and you tell it that you want to use the external temperature sensor, not the internal one. Otherwise it will be telling you the temperature in the cupboard that the thermostat is in, and not the remote temperature that the remote sensor is providing for you. You can also, there is a way also of wiring 4 of these into a large, if you've got a really large room, you can put 4 sensors into a room, and then you get an average temperature across all 4 sensors. Get in contact with us for information on how to do that. We've also got Standalone temperature sensors as well. So the previous temperature sensor, the invisible one, works in conjunction with the Omnistat, the thermostat. These guys are standalone. The extended range indoor-outdoor temperature sensor shown at the top left there, that's a standalone device. It wires back into the HAI controller. It'll give you the current temperature, and you've still got a low set point and a high set point that you can still set as an attribute of the device. But there's no display, no controls, no relays, so you'd have to manage your actuators using outputs off of the main controller. And there's a second variation here which also measures humidity as well. We've also got a water temperature sensor which is designed for pools or jacuzzis. So it's got a maximum temperature of sort of 50 odd degrees centigrade. So you can't use it for your hot water in your hot water tank. But it's designed for pools and jacuzzis, so you can decide whether to turn the heater on or not. Normally within the white piping for the filtration system in the pump, you can normally inject that silver probe into the system to measure the temperature. And obviously with the humidity aspects of things, again, you've got commercial opportunities there, greenhouses, wine cellars, as discussed before. So don't just think of domestic projects. There are bigger scopes available. If that wasn't enough, we've also got a range of ZigBee wireless devices. We've got a ZigBee wireless thermostat and a ZigBee wireless 240 volt relay. The thermostats still require power to power, and they still have the pin 6, pin 7 relays built in. But basically the telemetry of information back to the HAI controller is wireless using ZigBee protocol. So that allows you to do more retrofit situations because you don't need to get a Cat5 cable from the thermostat back to the main controller. Situations there, perhaps, if you look at existing thermostats on the wall for radiator-based heating, you've normally got a 3-core and earth to that 240 volt. You can obviously pull those cables off at the boiler end and pull the thermostat off at the thermostat end, with a Part P qualified electrician. And you can use 2 of those cores to send 24 volt AC to the thermostat, and then 1 core for pin 6 to bring your switching back again to the boiler room, which then will operate a relay to fire the boiler. So you can now retrofit these thermostats into an existing property using the existing wires, and you still get the control functionality because it's talking back to the controller via ZigBee. The ZigBee interface module shown top left, that's the device that ZigBee enables an Omni or a Lumina controller. It plugs into one of the RS-232 ports, and it is the ZigBee receiver and transmitter talking to the thermostats. And as I mentioned, we've also got a 5 amp or 30 amp 240 volt ZigBee enabled relay, so we can turn things off and on. You might use that to turn off and on the boiler if you can't get the cables back to the boiler, or you might use that externally to control the swimming pool pump or the heater, jacuzzi, external lighting, anything you like. You can switch at 240 volts without any need for any cables going from the relay back to the control system. So it opens up a lot more opportunity. We've also got this as a standalone system. There's 2 flavors of this controller. One, ZigBee enables the main HAI controller, or there is what's called a microcontroller where it looks exactly the same, but it's a standalone device. It powers off of a USB power supply, and then you can look at you can scroll through all your thermostats in the property, and it gives you a mini control system. It's got a really cool energy saving feature where it's got a button on top like a snooze button, and when you press that, you can set all the thermostats back by say 5 degrees centigrade for say 7 hours. So when you go to work in the morning, you tap that button, and then all of your thermostats drop back to an energy saving temperature whilst you're away, and it kicks back into normal temperature say 1 hour before you get home. So some really nice little solutions there as standalone, even without the main HAI controller. And you'll see more on the ZigBee side as new products roll out. That's pretty well it for this module. Places you can go to get more information. There's lots of great information on the HAI website. And of course on our website you can gain lots of information. You can steal those URLs there. Do follow us on Twitter and check out our company Facebook page. The new products are coming out all the time and we try to keep you informed using those routes, so do check those out. Thank you very much for listening. Hope you found this useful. Any questions you've got, you're welcome to contact us. And I hope you've enjoyed this, and look forward to speaking to you again on the next training module. Thank you.